In this lecture series, we'll learn about the naming and stereochemistry of cycloalkanes, or cyclic alkanes. Cycloalkanes are alkanes that form ring structures composed of CH2 units. They'll have the general formula shown here with n number of carbons and 2n number of hydrogens. Remember that our formula for an alkane, a linear alkane, is C2H2n plus 2. And so the cyclic version of an alkane just has 2 fewer hydrogens than the linear alkane. For example, propane has 8 hydrogens, while cyclopropane has 6 hydrogens. And we can think of taking a linear alkane and forming a carbon-carbon bond between the 2 terminal methyl groups. And in order to form that bond, we'll have to remove 2 hydrogens, one from each carbon. So while propane has 8 hydrogens, cyclopropane has 2 fewer hydrogens and has 6. We can illustrate that with a model. And I'm not going to use cyclopropane because I don't want to break my model kit today, but I'll illustrate with cyclobutane, or linear butane first as our example. Okay, in linear butane, we want to think about converting this linear structure into a cyclic structure, into cyclobutane. We would take each of the 2 terminal methyl groups and imagine forming a carbon-carbon bond between them. And in order to do that, because each of these terminal methyl groups, each of these terminal carbons, already has 4 bonds, in order to form a new carbon-carbon bond between them, we have to remove 1 hydrogen from each of them. And we can just imagine removing that hydrogen in order to form that new carbon-carbon bond between those 2 methyl groups, between those 2 carbons. Okay. So always the cyclic alkane will have 2 fewer hydrogens than the corresponding linear alkane. When we name cyclic alkanes, we use the cyclo prefix. For example, cyclopropane is our 3-carbon ring structure. Cyclobutane is our 4-carbon ring structure. Cyclopentane has 5 carbons. Cyclohexane has 6. And cycloheptane has 7, and so on. These are the cases where the cyclic structure is the alkane, or the parent, or the main chain, if you will. But we can also have structures where the cyclic alkane is appended to a larger chain. And so that cyclic alkane then is a substituent of a larger molecule. In these cases, we name the cycloalkane substituent by changing the ane ending to an eel or a YL ending, just as we did for alkyl groups. So here we have a cyclopropyl group, a cyclobutyl group, cyclopentyl, cyclohexyl, and cycloheptyl groups. When we name cycloalkanes, we follow the same steps as we did for linear alkanes. So if you need to, you should review alkane naming. But here we'll use the rules we've already learned, and we'll apply them to cyclic alkanes, or cycloalkanes. First, we'll identify the parent. And now the parent might be a ring or a chain, but it will be whichever has more carbons. So let's look at an example. Here we have a 5-carbon ring with a 1-carbon chain. So the ring will be the parent, a cyclopentane. In this example, we have a 3-carbon ring with a 5-carbon chain. So now the chain will be the parent, a pentane. Because we already know how to name linear alkanes, we'll apply the steps below to the cases where the ring is the parent. The next step is to number the ring. And because it's a ring, you'll be faced with a choice of how you number. You'll always want to use the numbering that gives the substituents the lowest possible total. So let's look at what that means. In this example, a trimethyl cyclohexane, I can start numbering at the red carbon and then move around the ring toward the closest substituent. We always move toward the closest substituent. I can start numbering at the blue carbon and then again move around the ring toward the nearest substituent. Or I can start at the green carbon and move around the ring towards the closest substituent. And now between these three choices, to identify which numbering is correct, we need to add up the position numbers for each substituent within each numbering scheme. When we add up those position numbers, we find that in the red case, they sum to 8. In the blue case, they sum to 7. And in the green case, they sum to 8. So the blue case, the blue numbering scheme, is the correct numbering scheme because it gives us the lowest total. In cases where a tie exists, you'll use alphabetical ordering to identify the correct numbering. Here in this example, we have a cyclohexane with an ethyl and a methyl group. And I can make the methyl carbon 1 and the ethyl carbon 3. Let's look at that numbering first. Or I can make the ethyl carbon 1 and the methyl carbon 3. Now both of these numbering schemes will sum to 4. Both have substituents in the 1 and 3 positions. So here to distinguish, we go alphabetically, and we give the higher priority, or the lower number, to the first alphabetically. So here comparing methyl and ethyl, the ethyl group has the higher priority. So the ethyl group will be position 1, and this compound will be named as 1-ethyl 3-methyl cyclohexane. The remaining steps are the same as we've seen for linear alkanes. We will identify, number, and name the substituents as we did in our example. And then we write the name as a single word. Let's pause for a concept check question. Take a minute to name the cycloalkane shown here. Okay, so to begin, we'll need to identify the parent. Here the parent is the 6-carbon ring structure, or a cyclohexane. Then we need to identify and name our substituents. We have a methyl group and 2 bromo groups. Okay, but what positions are they in? We need to identify the numbering of our ring. We can start at the methyl as carbon 1 or at the bromo as carbon 1. And if you try this, you'll find that both positions give the same total. So here we need to identify carbon 1 alphabetically. And so the bromo group receives higher priority than the methyl group, or the carbon containing the bromine is carbon 1. Then we number toward the next highest priority, or the other bromo group, and that will give us a 1-bromo, a 3-bromo, and a 5-methyl substituent. So the IUPAC name of this compound is 1,3-dibromo. Remember, we bundle those together if they're the same kind of group. 1,3-dibromo 5-methyl cyclohexane.